the participants, sir, students and teaching faculty have joined both on Cisco WebEx and YouTube platform. I welcome all of them on behalf of KSTA. It is a matter of pride and privilege that Dr. T.V. Ramachandra, who is a very busy environmentalist, has kindly agreed to join this webinar and deliver a talk on impact of climate change on ecosystem services. As you know, climate change is a very daunting problem for the humanity. Sir will be speaking on how climate change will affect or is affecting climate
No, I
and
am on the
ecosystem.
webinar. Can you call after some time, after 2 hours? Okay.
Before beginning the talk by Dr. TVR, I will just give a brief overview of his academic and academic excellence and experience. Dr. TVR is a fellow of many well-known associations, including FIE, FIEE, UK, FNIE, and he obtained PhD in ecology and energy from Indian Institute of Science. At present, sir is the coordinator of Energy and Wetland Research Group. He is also the convener of Environmental Information System, that's ENVIS, at the Center for Ecological Sciences. Sir has published many papers and he is a fellow of many well-known societies, including Karnataka Science and Technology Academy. Sir is a honorary fellow of Karnataka Science and Technology Academy. He is also elected fellow of National Institute of Ecology, Indian Association of Hydrologists, and Indian Social Science Academy, Institute of Engineers, etc. Dr. Ramachandra sir is a recipient of many awards, important one being Karnataka State Parisara Award in 2017-18 from Government of Karnataka. He is also a recipient of Satish Dhawan Young Scientist Award in 2007 by Karnataka government, and he is also a recipient of World Communicators Day Award by PRCI, and sir is DVR sir is he features in the recent global ranking of top 2% of scientists developed by a very well-known and renowned institute, Stanford University, with the ranking in environment of 0.1887 and many more. And sir has guided 152 students for their master's dissertation and 17 PhDs he has guided, and we are very proud that sir is a very well-known environmentalist, and he has published more than 352 research papers, 75 book chapters, and 333 papers in international and national symposium, etc. It's a matter of privilege that sir has agreed to deliver a talk on impact of climate change on ecosystem services. Now I request sir to take over and distinguish talk. Hello.
Okay, thank you, sir. Thank you for the good introduction. Now I will start my presentation. As we have lost already 10 minutes, I'll straight away get into the presentation. Am I audible to? Hello?
Yes, sir. You are audible, sir. You are audible, sir.
Okay. So the slides are visible?
Yes, sir.
Okay. So, that today I'll be talking about the climate change and also what is its impact on the ecosystem services. Finally, it is going to affect all of us. That's what we need to understand. I'm going to establish that through my presentation. So now we all know the changes in climate is happening, where the flooding happens, loss of life and property happens, and we are facing the floods and things, whether it is Himachal Pradesh recently or in Jammu Kashmir. Very recently, we all face the thing. And now currently the government, the Karnataka is undergoing the green drought. There is a dry spell and it has affected the food productivity, etc. Now, let us try to understand what is climate change. The increase in temperature is the the average temperature, there is a change in average temperature and cycles of weather over a long period of time. That is the change in the climate. Because of the increase in temperature, there are other climatic the variables also get altered. You will not get the rain when you want, or when you want rain, you are not having this one. Okay, so that means, and also the planet is becoming warmer. So, for example, today, if you look at the last 1 week, the Bangalore has been experiencing a very high temperature, 31 to 32 degrees Celsius, which shows that we are already in the era of changes in climate. Now, let us try to understand why the climate change is a problem. One is, with the climate changes, we have noticed the instances of natural disasters are increasing. It could be the floods, the wildfire, etc. So, and the sea level rise is also increasing. So now there is a rise in sea level, the coastal population becomes more and more vulnerable with the increase in the sea level. So then, if you look at the ice melt is happening. Now, when you look at the image, you will see the ice melt. This is in the way back in 1981, and today the ice melt is this white portion is the ice covered in the thing. See, now when the ice has covered the region, the bright surface of the ice reflect 80% of the sunlight, and that hits back into the space. This keeps the polar regions cool and moderates the global climate. When the area of the sea ice is reduced, like what we saw from that orange line, it comes down to the white. So the less sunlight is reflected back into the space. This causes more ocean warming and reduces the sea ice even further. This feedback drives faster the changes in climate. So now, what causes the changes in climate? See, we all know the greenhouse gases, the carbon dioxide, the methane, the water vapor. These are see, when there is a solar radiation, the short wave, the radiation passes through the and reaches the atmosphere. So in the normal phenomena, if the greenhouse gases are not too high, then you will not have the warming of the earth. But when the concentration of the greenhouse gases increases, so then we have the problem of the global warming. The greenhouse gases include carbon dioxide, nitrous oxide, methane, and fluorinated gases. And when you have the higher concentration of the species of carbon or the nitrogen, etc., in the atmosphere, what happens is, whatever the solar radiation that has come to the earth, the emission happens in the longer wavelength. That longer wavelength, this one, when that interact with these greenhouse gases, which absorb this energy, and it makes the earth warmer. So that means the energy that has entered the earth is not escaping from the earth. In the process, we see the warming of the earth happening. Okay, so now, see, what are the causal factors? One is the emission happens when you burn the fossil fuel, when you generate electricity using the coal, oil, etc. Then the second thing is the deforestation. See, the deforestation is a much more serious issue, because when there are trees in the forest, the trees used to do the job of carbon sequestration. During photosynthesis, they used to take the carbon dioxide, they used to absorb the carbon dioxide from the atmosphere, and you have a lesser concentration of the carbon in the atmosphere. And because of the removal of the trees in the forest area, we lose that capability to sequester the carbon. Apart from that, the carbon that is stored in the soil get released. That means the emission also increases. That's why the deforestation has the compounded effect of the emission and also the loss of ability to sequester the carbon. Then the reduction of biodiversity. The native species are resilient to the changes in climate. But when we lose this, the resilient, the system, naturally the system become vulnerable, and you will have the problem, and the loss in the system will also lose the ability to sequester the carbon. So that means the earth become more less resilient to the rising temperature. So now, when you look at who causes the climate change, now if you look at on the earth, we all know that we have one earth, but there are many countries on the earth. Now, when you look at across the country, you will see that the 50 least developed countries are thought to have contributed 1% of the greenhouse gases. Okay. that have caused the global warming. The USA, the European Union, and China have contributed around 60%. These global giants, the USA, EU, the European Union, and China are responsible for the increase in the greenhouse gases in the system. Now, to summarize what I said so far, when you look at the increase in the temperature is because of the carbon species that happens because of the industrial emission or the deforestation or for the agriculture. When you look at the sector wise, you will see the burning of fossil fuel constitute 49%, while the agriculture you have 13%, deforestation contributes 14%, and industrial processes is about 24%. Now, when you look at the species of the gases wise, the greenhouse gases, you see carbon dioxide constitutes 64%, while the methane is about 19%. As you all know, when we cultivate paddy, there is a methane generation, or in the dairy farming, we have the methane generation. Then chlorofluorocarbon constitute 11%, nitrous oxide is the 6%. That means that, if you are talking about bringing down the carbon emission, first thing is we need to bring down the fossil fuel burning, and also we need to arrest the forest, the degradation or the loss of forest, and we need to have innovative practices in the agriculture. That is where when we talk about talent search, we are looking for the youngsters who can think of the innovative solutions towards the thing. For example, when you look at the energy, we need to look at the alternatives to the energy which does not contribute to the greenhouse gases. It could be the renewable source of energy like solar, wind, etc. In addition to that, there is a scope to convert the residues into the energy. For example, you see that in the Punjab and Haryana and Uttar Pradesh, people burn the stubble for the after harvesting the crop, whatever the stubble that is left on the ground, they just burn it, which contribute to the emission. Now, if you think about converting that stubble or the straw into the ethanol, that is the thing. That is where we look for the talent which who can think innovatively and come up with a viable solution. There are challenges, but we need to they overcome the challenges and take that as opportunities in our career so that we can come up with a viable solution to this one. Now we understood the sector wise and also the emission that is happening in the various sector. So now let us try to understand why this climate change is a problem. Now, for example, you all know coral bleaching is happening. With a 1.5 degrees Celsius increase in temperature, we lose 70% of the coral. Now, another 0.5 degrees Celsius we will lose about 99% of the coral. Similarly, if you look at the species on the earth, you would lose 6 species will go extinct at 1.5 degrees Celsius, and the 8 plant species is likely to go extinct, and similarly the 4 vertebrate species is likely to go extinct with a 1.5 degrees Celsius increase in temperature. Now, if there is a further increase of 2 degrees Celsius, then you see that the insect, instead of 6, you will see the 18 species will go extinct. Similarly, the plants, 16 species, and vertebrate 8 species. Then if you look at the drought, there are, the million areas affected because of the drought is about 350 million. Now, with a 1.5 degrees Celsius. Now, if the temperature is increased by another 0.5 degrees Celsius, you will see that 410 million, the area, the people are going to be affected because of the drought. Then rise in sea level, there would be with 1.5 degrees Celsius, the sea level rise is about the 48 centimeters. And about 46 million people are going to be affected who are there in the coastal areas like Chennai, the west coast of Karnataka, etc., and Kerala. Now, if there is a further increase of 0.5 degrees Celsius, you will see that the sea level would increase by 56 centimeters, and we lose, and about 49 million people are going to be affected. These are all will make the earth vulnerable, and we lose the food, and we lose the place to live, the near the coast, etc. And with the drought, we cannot grow the crop. Now, which are the regions on the earth going to be affected? If you look at, we will be exposed to the water stress. Okay, 120 million to 1.2 billion in Asia, 12 to 81 million in Latin America. So then you see that possible yield reduction in agriculture will happen by 30% by 2050 in South Asia and Central Asia. and 30% by 2080 in Latin America, and about 50% the yield reduction in South African countries. The India, we are going to face about the loss of 60% crop by 2100. So that means, we are going to have the problem of the changes in climate is the sea level rise, increase in temperature. With increase in temperature, the other problem is the vector-borne diseases will increase. That is where we are going to face the problem of chikungunya, the dengue, then the COVID, etc. Then the glaciers will melt. Then you have the temperature increase, sea level rise consequent to that. Then there are frequent flooding and drought in the region, and decline in the crop productivity will happen. Okay. Now, all this will lead to the loss of water availability, which will result in food security, the insecurity, and the cities become vulnerable. Coastlines, the coastal regions become more vulnerable, and of course, with the vector-borne diseases, the public health also gets affected. That is where we need to mitigate the changes in climate through the conservation of ecosystem, and we need to identify ecologically vital regions, and conserve that. And second thing is, we need to identify the climate resilient crop so that we don't face the food crisis. That is where the millets or the pulses or the crop that we can think about it. Similarly, we need to look at the energy, the sector wherein we should bring down the emission by going in for the viable alternative like the bioethanol, biodiesel, the methanol, etc., solar energy, wind, etc. Okay. Now, who can fix it? See, the government has to make the policies to bring down so that is what we notice. The governments are making the policies to bring down the thing. And in the recent COP meeting also, from COP, the Paris meeting, we have been talking about decarbonizing the atmosphere. To decarbonizing the atmosphere, we need to bring down the fossil fuel dependence. So that is where the government, the business houses, and the industries, and we all can make the thing. Instead of using the fossil fuel based electricity, if you think about solar energy, if you have a rooftop solar harvesting, you are doing in your own way your contribution to minimize the changes in climate. Okay. So now the new opportunities, that is where we are looking for the talent. Transition to a low carbon economy in the years ahead brings with it many opportunities. When you start thinking of low carbon economy, you need to innovate. Innovation is the process of turning an idea into a solution that solves a problem. So that means whatever the problem we are facing today, through the innovation, we can make that as an opportunity. Transitioning to a low carbon economies will provide lots of opportunity for innovation. That means the youngsters of today will have an opportunity to this one. That is where the talent is required. And these opportunities are exciting. And there will be a need of people leaving education to do things differently, to come up with new ideas for products and technologies, and to explore new conservation methods. Now the nature-based solutions is picking up. At the end of my talk, I will give some of the examples of that. Then new job sectors will be created and new skills will be valued in the jobs market. So that means a different job market will emerge. So that means we'll be thinking about nature-based solution, climate resilient crop, then innovation in the energy sector, and bringing down the carbon footprint in the system. So that means you will have to think differently. You cannot go with a conventional degree and then think in the same way as it used to happen in the last 2 decades. Now, for you to survive in the system, innovation is the order of the day. So now, see, the key mitigation instruments, the policies and practices are the research, development, and demonstration. That means you need to come up with the appropriate viable technologies, appropriate energy infrastructure. For that, of course, investments are there, regulation and standards, taxes and charges, changes in lifestyle and consumption pattern, so that you have a low carbon footprint. If all of us have a low carbon footprint, we can bring down the global warming and the consequent changes in climate. Okay. Then now with this background, let us try to understand what is the agenda of our research. The agenda of the research is to maintain the clean air and water and environment to the next generation. For that, you need to maintain the ecosystem. Then only you will have the natural resources with the minimal disasters. Otherwise, with the changes in climate, you will lose the natural resources and the disaster become very frequent, and there won't be security, survival and peace on the earth. Now, if you want looking for a sustainable future, you need to plan. You need to maintain the ecosystem integrity. That is where the responsible decision making with a decentralized governance, and with that, you will be able to manage the natural resources effectively. Now, let us try to understand the nature principles in a better way. See, for example, if you look at a food chain, which you would have studied in your school days, when you look at the food chain, you see the producers are producing the food which is eaten by the next level, herbivore and carnivore. Now, when you look at this, every organism depends on the other organism for food. But if you look at from the thermodynamic perspective, you see the energy and material transfer happen from one level to the other. And finally, whatever is left in the system gets converted into elemental form by bacteria and fungi. That means when you look at the nature, there is nothing called waste. That means if you think about the nature-based solution, you can minimize the waste that is happening on the earth. Similarly, you can think about converting the waste to the wealth, similar to the what bacteria and fungi are doing. You know that today bioremediation, or if, using plants for remediation or the treatment of water, soil, etc. through the microorganism is an emerging area. You know, that is one area you can think about doing the science or making your career. Okay, so then let us look at the diversity that is there on the earth. You know, as per our scriptures, there are 8 to 12 million species are there on the earth. You know, as per the science, we have estimated about 1.3 million species. What do we mean by 1.3 million species? That means you have a diversity of plants and animals. When you have diversity, that means varieties of plants and animals, you will have variety of food, and because of variety of food, you will get the immunity. You know, that means the diversity gives the health to the people. Diversity gives the immunity to the people. Now, to understand this, I will take you to the Western Ghats, which extend from Kerala to Gujarat, from 8 degree to 22-degree latitude. If you look at the Western Ghats, the entire Western Ghat region constitute only 5% of India's geographical area. But if you look at the Western Ghats, what is the job it is doing with a good forest? There are 100 plus rivers. You know, because of that water from the river throughout the year, we have the water security in the peninsular India, that means southern India. And because of the water security, we have the food security. Not only the food security, we have because of the diverse food, we have the medicinal, the benefit and also immunity. That means the Western Ghat is been providing us the food, medicine and immunity. Now let us look at the number of species where it occurs. I said that Western Ghat extends from 8 to 22-degree latitude. Now when you look at the Western Ghat, when you look at the number of species on the earth latitudinally, you will see that at 8 to the 14-degree latitude, you have the highest number of species. This 8 to 14-degree latitude corresponds to the Kerala, Karnataka and Tamil Nadu part of the Western Ghat. So that means we all have inherited the earth, and we are fortunate to be in the Western Ghat part of the India with a diverse the ecosystem and diverse plants and animals. So that means it's the responsibility is on our shoulder to conserve this fragile ecosystem and pass it on to our next generation. You know, when we do that, that is what is called a sustainability, ensuring the clean air and water and environment and food to the next generation is the sustainability. Now, let us look at how the changes are happening. Now, again, you know, this is where you can think about analyzing the data. You know, now the picture of the earth is taken from the satellites. We launched the satellites way back in 70s. You know, every 21 or 18 days or 30 days interval, we keep on taking the picture of the earth. Now, with that big data, you know, if you are getting the data from 1970 till today at 21 or 18 days interval, you have the massive amount of data that is called a big spatial data. You know, to analyze the data, you need to develop the algorithms, or you need to have see, earlier to analyze this conventionally, we used to take for one district, it's almost a year. Now today, because of the artificial intelligence and machine learning, the entire Western Ghat was studied by my students in about 6 months' time. The advantage of the studying the Western Ghats, the land cover, is that you will see what changes are happening. When you look at the land cover changes, you will see the green is reducing. We have lost about 5% of evergreen forest in the Western Ghats during the period 1985 to 2019. Not only we are losing the forest, forests are also getting fragmented. That's what we see from this image. More and more patch and perforated forests are coming in the place of where intact forests were there. So these are all going to affect the biodiversity of the region. Now let us look at what is the service these forests provide. As I said earlier, the vegetation during photosynthesis take away the carbon from the atmosphere, which is stored in the tree, in the stem, the leaves, etc. So that means they are helping in moderating the climate and the earth by bringing down the carbon, by sequestering the carbon. Now we can quantify how much carbon is stored in this the vegetation by measuring the above ground biomass, below ground biomass, and the soil. The carbon is stored in the soil, and similarly the carbon gets stored in the above ground, the in the tree portion, and also in the roots, etc., below ground. So we have done the quantification of that above ground, below ground, and the soil. And our estimate shows that about 1.23 million gigagram of carbon is stored in the vegetation as well as the soil in the Western Ghats. Now, every year, about 37,000 the gigagram of carbon gets stored by the plants or the vegetation in the Western Ghats. Now, this 37,000 gigagram amounts to the carbon emission that happens in the cities like Trivandrum, Cochin, Mangalore, Bangalore, etc. That means the nature tried to maintain the balance. That is where you need to protect the forest, protect the Western Ghats so that you can maintain the balance. Now, if you give the economic value to the carbon service, the service provided by the forest, it amounts to about 100 billion rupees or a $1.4 billion. This is the thing. Now how this number would help. For example, when I go to the international meeting, I tell them that the Western Ghats forests have stored the carbon that is emitted by the industrialized countries. The service provided by the Western Ghats forest is about $1.4 billion or 100 billion rupees. That is the amount the Western countries have to pay the India for the service provided by our fragile ecosystem, that is the Western Ghats. Okay. So now we also have predicted what is the likely scenario by 2031. We have seen there would be further the reduction in the forest cover, and there is a further the fragmentation of the forest in the region. Not only that, consequent of that, there are changes in temperature in the region. There would be an increase of 0.5 to 1.5 degrees increase in the temperature. The Kerala will become warmer. Now with the warm the Kerala, then you cannot practice the wet cultivation. Then you will have more and more the COVID and the other vector-borne diseases. And other worrying factor is changes in rainfall pattern. Kerala, which receives the rainfall for 6 to 7 months, a higher amount of rainfall will start getting the low rainfall. So is the Karnataka also. So then if you look at the rainy days, the rain which is spread across the 4 to 6 months, 4 months in Karnataka, 6 months in Kerala, will start coming in few weeks. When you get a large amount of water in a shorter duration, we refer that as a high intensity rainfall. When there is a high intensity rainfall, you will see there are flooding. Consequence of the flooding is the landslides and mudslides. That is what we need to understand. The mistake of degrading our forest, our children are going to pay the heavy price in the form of the floods. They have to face the vagaries of the climate through the flooding, landslides, mudslides, etc., and increase in the temperature. That is where you need to conserve the ecosystem. To conserve the ecosystem, we thought it's better to develop the decision support system or the expert system. So that is what we did for the Western Ghats. We considered all the data. We compiled the data of the Western Ghats over the last the 3 decades, related to the land, the forest cover, etc. Then the ecology, where all the flora, fauna is there. Then the climatic variable, hydrogeology, energy, etc. We combined all of them and assign the weight. That when we assign the weight, we got which are the regions which are the ecologically important, which are degraded, etc. That we designated as ecologically sensitive region. To do this analysis, we divided the Western Ghats into 5 minutes by 5 minutes grid like this, or the 9 kilometer by 9 kilometer grids. In each grid, we computed what is the forest cover, what is the flora, fauna, rainfall, etc. We assign the weight based on the variable status. See, that is, for example, you see the forest cover. From the remote sensing, you know where the forest cover is high. We have assigned 10 for a very high forest cover of greater than 60%. Similarly, wherever intact forests are there, greater than 60%, we have assigned the weight of 10. The less than 15%, we have assigned the weight of 2. You see that we have divided the entire study region into the grids. So when you divide into grids, you can look at the decentralized level what changes are happening. Okay. Then this gives the flora and fauna distribution. This is the plants in the Western Ghats, which include the trees, the herbs and shrubs. Similarly, the fauna. Based on the endemic species and the threat status, we have assigned the weights. Okay. Then we looked at the tree endemism as well as the fauna endemism. When you look at fauna endemism, the endemism of the animal is higher in Kerala, Karnataka, and Tamil Nadu part of Western Ghats. So is the tree the endemism. Endemic species, that means the species that occurs only in that region, is higher in the Kerala part of Western Ghats, so is in the Karnataka part and the Tamil Nadu part. So this gives the carbon sequestration. Based on that, we have assigned the weight for this. We followed the standard protocol of the quartet-based, the transect-based quadrant to do the mapping of the flora and fauna in the region. Then integrating all these variables, then you have aggregate score. Based on the aggregate score, we did the frequency distribution analysis. Based on that, we divided the region into 4 levels. You have ESR1, ecologically very sensitive. ESR2 is ecologically sensitive. ESR3 is moderately sensitive. ESR4 is not that sensitive. So that means we have identified the region which has to be conserved on priority, that is ESR 1 and 2, while we also said where the development can happen in the region. Okay. So now we develop the decision support system, which is available online. So you can see that you can visualize at the state level, district level, or a taluk level, and also at the village level for the entire Western Ghats. That will help you. And also we have provided the details about this decision support system and related publications. We have placed it in the say when you access this web page, you will get the details of this decision support system in various vernacular languages, also the southern languages, and they also the videos are available which highlights the importance of this decision support system, and you can also visualize this one. And the same thing, we applied the app, this one, which is available in Google app, which is known as Sahyadri. Using this QR code, you can download, you can install it on your the mobile, and you can also visualize this one. Now to show you that this region, now I will take you to that decision support system. I'll demonstrate it online. So now when you access this web page, it looks like this. So okay, you can click on the Western Ghats Spatial Decision Support System. Okay, so now when you look at this, see, if you are interested in a particular state or a district, you can find out what is the ecologically sensitive next. For example, if you want, you can choose Karnataka, the district. See, as we all face the flood and all in the Kodagu, I will choose the Kodagu region. So you can see that I have chosen the Coorg. See, now you got the Coorg. You can see at the village level where all the ecologically sensitive villages is 1, then the 2, and this is 3. Okay. Then you can also, if you want, you can go to the particular taluk. You can choose the taluk. Then in a taluk, if you want the village, you can do that. Okay. So now if you want the information related to that, you click on that. You will get the details why that is ecologically sensitive. All the parameters are put there. Similarly, whatever the data that we use, we have made it available to the public at this location. So now that means you can also use this the app to download the you can use this QR code to download this app. Okay. Now with this, let me take you to the other part. The that is about the why we need to conserve the ecosystem. So for example, I will take you to a river basin in Western Ghats. I'll show the two situation. One is 91 and today. See, in 91, I see the abundant water in the region, but today, the same day, same month, I don't have the water. Okay. Now let us try to understand what could be the reason. When you look at this picture carefully, you will see when the water was there, there was a vegetation. That means when there is a landscape is covered with vegetation, it does the various function like the hydrological cycling, the nutrient cycling, the water cycling, the biogeochemical cycling. Now to understand this further, let me take you to the river basin and explain this further. This is a Sharavati River basin. Originates at Ambutirtha in Shivamogga, traverses 128 kilometers, and we constructed a dam way back in 1964. After constructing a dam, there is the forest in this region got degraded. You can see from this remote sensing data, you see this region has the forest cover, while this region, the forest is degraded. Now, the implication of that, the streams which are there in this region, wherever forests are there, stream density is higher, while in the degraded patch, you see the stream density has come less. And if you want to look at what is the impact on the rainfall, let us look at the rainfall data, which is available for 123 years. That means from 1901 onwards, you get the rainfall data for every day. You download that data, divide that into two time period, 1901 to 1964 and 1965 to today. When you analyze that, 1901 to 1964, this entire region was receiving the rainfall of 3,000 to 4,500. But after 1965, if you look at this portion, receives the rainfall of 3,000 to 4,500, while this region started getting the rainfall of 1,700 to 1,900. That means this portion where forests are there, rainfall remained the same, 3,000 to 4,500, while the other portion, which is degraded forest, you see the rainfall is 1,700 to 1,900 millimeter. Now, we'll also look at how the forest cover in the region also at the basin level. We divided the region into the sub-basins. You see, wherever the forest cover is higher, rainfall quantum is higher. Forest cover is 65%, rainfall is 4,800, while the forest cover is 46%, rainfall is 2,100. Or the forest cover is 60%, rainfall is 4,400, which establishes the link between the forest and the rainfall. Now, whatever the quantity of rainfall, but how much water is available in your well or in your stream matters in the livelihood. So to understand that, what we did is we deployed the sensors. We insert the sensors in the underlying layers of the earth. See, when it rained, to quantify how much water get infiltrated during the monsoon, when it rains, we chose the representative catchment. One catchment dominated by the native species forest, another one with a monoculture plantation, the other one with the urban area or the concrete jungle, like that. When the catchment is dominated by native species forest, since the native species forests are diverse, the roots are diverse. When the roots are diverse, you have abundant soil microorganism and a diverse microorganism. When the soil microorganism is abundant and diverse, it makes the soil porous or permeable, which is evident from the low bulk density. When the soil becomes porous or permeable, when it rains, it allows the water to percolate. It fills this zone, which is a groundwater zone. Then it fills the vadose zone. Then after filling this underlying layer, then only the water flows in the river or stream in the region. Now, what is the benefit of the water getting stored? See, you have rainwater for 4 months because there is a rainfall of 4 months. Then after 4 months, the water that is stored in this region moves laterally to the river or stream or a lake for the next 4 months. That's how you have the water for the next 4 months after the rainfall. Then during the summer, the water that is stored in the groundwater zone, they comes to the river or stream for the next 4 months. That's how you have the water for 12 months. Here, where the urban areas are there, concrete buildings are there, no infiltration happens. Because of that, only during monsoon you have the flood, and there is no water during the post-monsoon. Based on this, in our study sites, we graded the streams as A, B, C, D. A are the stream which carry the water for 12 months, B for 8 months, C for the 6 months, and D for 4 months. Now, when you look at this, A type of streams are A type. That means it carry the water for 12 months when the catchment has a forest cover more than 60%. When the catchment is degraded, is converted into monoculture plantation like coffee, rubber, or acacia, you see the streams carry water only for 8 to 6 months. That means it becomes either B or C. When we degrade the catchment with a forest cover less than 40% or a 30%, you have the water only during the monsoon. Now, to summarize what I said, see, this is the region where the this shows this is a region where the good forest cover is there. If you look at the amount of water that get infiltrated during the monsoon, it amounts to about 55 to 60%. Whereas in this region, the forest degradation is there. The amount of the water that gets infiltrated during the monsoon is only 28 to 30%. Now, we also looked at what is the societal demand. You see that people require water for agriculture, livestock rearing, fishing, etc. When we quantified that, there's a you see in this region where forests are there, the demand for water is higher, but there is a sufficient amount of water. Whereas where the forests are not there, there's a shortage of water. You see the demand is much higher than the availability. Now, to summarize what I said so far, this one, you see that this is the region you have 12 months water. This is the region, the green one are the 8 months. This is 6 months, and the blue one are the 4 months. When you overlay the forest cover, you see wherever forests of native species forests are there, you have 12 months water. You have 8 to 6 months of water depending on the extent of fragmentation of the forest with the intrusion of monoculture plantation. Where the forest is degraded with the forest cover less than 30%, you have the water only for 4 months. Now you might ask, what is the use of this? Look at the livelihood of the people. The farmers in this region, if they earn 1,54,000 rupees per acre per year, farmers in this region, they earn only 32,000 rupees per acre per year. That is mainly because, since the water is available throughout the year, farmers can grow multiple crop or a cash crop so that their earning is 1,54,000 rupees per acre per year. Whereas in this region, since water is available only for 4 to 6 months, they can grow only one crop. That's why the earning is only 32,000 rupees per acre per year. And other thing is, when you look at the yield of the crop, wherever forests are there, there is a higher number of pollinators like insects, the honeybees, etc. Because of the pollinators, pollination is efficient. When pollination is efficient, the yield of the crop is higher. When you look at for example, the paddy yield is about the 12 to 18 quintal in this region. Whereas in this region, because of the poor pollinators, the yield of the crop is 6 to 8 quintal per acre. The government of India, Prime Minister Modi, talks about doubling the income of the farmers. My suggestion to him is, if you want to double the income of the farmer, there's a nature-based solution. What is the nature-based solution? Maintain the ecosystem integrity so that farmers have the water, and because of the water, they have the higher revenue, and because of the multiple crop with the higher the pollination, they can have the double yield also. Now, let us look at the other biodiversity that are there in the region. Wherever water is available throughout the year, you will see the animals like sloth, bear, tiger, etc. Where water is available only for 4 to 6 months, in that region, only I saw the two-legged animal. So now let us also try to understand the beneficial aspect of the fauna in the region. We described the two new species of the fish. They also have medicinal properties. We thought that because of the medicinal properties, we can make big money. No, we brought those fish to the Bangalore. We tried to culture it. When we cultured and analyzed the medicinal properties, these fish didn't have the medicinal properties. The message is here, if you want medicine, then we need to culture this fish in its habitat. For the fish to survive in its habitat, in that river or a stream, the stream or river should have the water 12 months. For the stream or river to have water 12 months, surrounding catchment area should have the forest of the native species. That means this fish highlights the linkage between the aquatic diversity with the terrestrial diversity. Now, let us try to understand the implication of changes in climate through the another example, the frogs. As you all know, frogs are known as amphibians. That means, they have two stages in their life cycle. The juvenile stage, the tadpole stage is in the water. The adult stage is in the land. Because of the two stages in the life cycle requiring two different kind of habitat, we call frogs as amphibians. Now, if the water is not there on the earth, with the global warming, changes in climate is happening. With the changes in climate, the water will not be available on the earth. When the water is not there, what will happen to this organism? The tadpole cannot survive. But we come across one particular species, the Philatus leucorrhina, the frog. It has bypassed the tadpole stage because of the water scarcity. The stream where it was surviving, we notice that stream has become a seasonal. So then, but this frog continues the progeny. So the fertilization of the egg, we didn't see the tadpole stage. On the 14th day, we saw the younger ones emerging out. So that means the frogs have learned how to get adapted to changes in climate. Whatever our the innovations, whatever our ability to think, but we need to go in between, in front of the nature. With the scarcity of water that no humans can survive, only these organisms will survive on the earth. Okay. Now, let us, understanding this importance, our elders have protected the patch of forest. They declared that as the sacred forest, or Devarakadu, or the cause. They realize that if the forests are there, there is a water in the well. If there is a water in the well, they have the revenue in their farm, etc. But unfortunately, that is now getting converted into the idle land. Okay. Now, let us also look at how the history teaches us about this. For example, if you look at the Easter Island, you know, the people thought that land is available. They went on expanding the land. One day the island has to, the people have to abandon the island because of the water scarcity. Similarly, if you look at in our country, last leg of Vijayanagara kingdom failed because of the water scarcity. That means, the water availability on the earth decides the fate of the humans. Now, if you want to have the water on the earth, you need to maintain the physical integrity and the chemical integrity. That means you should not alter the physical integrity of the system. You should not pollute that is the chemical integrity. You should not alter the chemical integrity of the system. When you have the physical and chemical integrity in place, you will have the biological integrity. That means the species that are there in the particular region will continue to be there. Okay. So now, let us also look at the ecosystem services. We try to quantify what is the worth of this forest in this one. We have looked at what are the tangible benefit people get. We call that as a provisioning services. People get timber, the food, the crop, etc. from the forest. They get the fodder, the grass, etc. We found out what is the quantity of that, what is the benefit of that. From that, we computed what is the worth of this one. For example, if you are growing paddy, let us say per quintal you are selling at 1,000 rupees, you would have incurred the expenditure of 600 rupees. That means for a quintal you are making 400 rupees of profit. Now, considering that profit with the quantity grown in the thing, we can say what is the revenue at home. Similarly, for the ecosystem, we find out what is the quantity, and also we find out what is the price and the cost. P minus C gives the benefit. So like that, for each item, we found out what is the benefit. Similarly, we found out the regulating services like carbon sequestration, the quantity, etc., and cultural services. What is the worth of that ecosystem in terms of the aesthetic, sacred grove point of view, etc. The aggregation of all this provisioning, regulating, cultural gives the total ecosystem supply value, which is also known as the gross ecosystem product or the green GDP. We all talk about GDP, gross domestic product. What we are talking about is the green GDP. That means we are accounting this the contribution by the ecosystem in our GDP. Okay, and also we account the degradation cost in the GDP. See, when you propose some project, because of the project there is a degradation, we need to account that degradation cost in this, and that is called a green GDP. Now, we have done that quantification for the district wise for the entire Karnataka. What are the various goods like the timber, bamboo, etc. from the forest. Similarly, we quantify the regulating services, the district wise and cultural services. This gives the total ecosystem supply value. Because of the time constraint, I am giving the total value. You see the value of the forest in the 2005 at 2019 price is about 2,894 billion rupees per year. Whereas the same forest, because of the degradation, the worth has come down to 1,835 billion rupees per year. Now let us see if you are getting the revenue of 1,835 billion rupees per year or a 2,895 billion rupees per year, what is the asset value of the forest? Say, for example, when you keep 1,000 rupees in a bank, at 10 rupees interest, the interest, you will get 100 rupees every year. That means to get 100 rupees every year, you need to keep a principal amount of 1,000 rupees. Similarly, to get a 1,835 billion rupees every year, what is the principal amount equivalent of that the forest? We have computed that. See, this gives the various this one for the forest and the agriculture, etc. So that we saw that 2,841 billion rupee per year has come down to 1,835 billion rupee per year. Now with this, we computed the net present value or the worth of the forest ecosystem. You see that the worth of the forest ecosystem was 73,000 billion rupees in 2005, has come down to 47,000 billion rupees. Now with the changes in climate, you will have the reduced productivity and we will lose this asset further. Now with this, let me bring you to the Bangalore. For another 10 minutes, I will talk about Bangalore, what is happening, because we work on lakes of Bangalore and trees of Bangalore. Let us look at what are the things, the climate, what are the changes that is happening. You all would have experienced the increase in temperature. That is because of the unplanned urbanization with the loss of trees and the water bodies. The trees and water bodies acts as a heat sink. That's where they help in moderating the climate. The decline in vegetation cover, loss of riparian vegetation, and of course the discharge of untreated or partially treated wastewater into the lake. Then the waste mismanagement. When there's a mismanagement of the waste, you see there is the emission of the methane. When there's a methane has a global warming potential 24 times than the carbon dioxide. That's where you have to be extremely careful when you are managing the waste. You need to make sure that waste is not mismanaged. Waste is not is appropriately managed. Okay. So now let me take you to the Bangalore. When you look at the Bangalore, it's a small hillock. The highest point is here. Incidentally, IISc is located at this highest point. We are number one in the country academically. Not only, even the location wise, we are the top of the Bangalore. When you look at Bangalore topography, we have three watersheds. In this area, way back in 1800 during Kempegowda period, we had 1452 water bodies and 82% green cover. Because of that, temperature in the region was 14 to 16 degrees Celsius. And for few days in December, the temperature was 0 degrees Celsius. But today, if you look at the number of water bodies has come down to 193 and the vegetation cover less than 8% and temperature has gone up to 34 to 37 degrees. Okay. Now, the lakes in Bangalore were interconnected. We have lost the interconnectivity. Because of that, flooding is happening in the region. With the changes in climate, we are getting the high intensity rainfall. That is where we are paying the price in the form of flooding. Okay. Now, we have also looked at what is the worth of the water bodies in the thing by quantifying the provisioning, regulating, and cultural services of the 193 water bodies in Bangalore. When you look at the wetland, you see the groundwater table happens. Wherever lakes were there, the people are getting the water at 80 to 100 feet. When the lake was removed in 6 years, the water table went down to 600 feet. And today, after 22 years, in the same location, people have gone down to 1,800 feet. There is no water. This is the message to the Bangalorean. If you go on removing the lake, then we will not have the water in our wells. And 45% of Bangaloreans depend on the groundwater. So now we also looked at what is the worth of the lake, if it is the pristine state and if it is the polluted. When the lake is not polluted, people get fish, fodder, they can do agriculture with the water from the lake, which amounts to 10,500 rupees per day per hectare. But when we pollute the lake, the value come down to 20 rupees per day per hectare because there won't be fish, there won't be fodder, etc. Who are the people who depend on the lake? Fishermen, washermen, farmers, etc. and researchers like us. And who are the people who pollute the lake? The people who reside in the city. They are the ones who pollute the lake. That is where you see the livelihood of the people also in the vicinity of lake are affected. So now, if you look at in Karnataka, we have about 39,000 wetlands. We have done the quantification of the thing. The wetland worth is about 7,320 billion rupees. And every year we get the revenue of about 284 billion rupees every year from the wetlands in Karnataka. Then we also looked at what is the threat for the wetland. One is, as I said earlier, unplanned urbanization. You see the Bangalore, which had a 68% green cover. That means the vegetation, and blue is water body, yellow is open space, and the red is the building. You see now in 2023, 86% is red. You see only the concrete. Earlier we used to see the building, we used to see the vegetation, trees, and actually the Bangalore was known as a garden city. 1973, 68% green cover. Then 92, with the industries coming up in Pune and Koramangala, you see the changes happening there. Then the 2000, you see the IT, BT sector coming up in the outskirts, the changes has happened. Then 2006, further intensification. 2009, further intensification has happened. And 2021, you see about 84% of Bangalore landscape is concretized, and 22, 85%, and today 86%. If this trend continues, 98% of the Bangalore would be concretized. With the loss of the vegetation, with the 1,055% increase in the concrete area, we have lost 88% vegetation and 79% of the water body. And the situation in Bangalore is we have the oxygen deficiency and also the water scarcity in the region. Some elders in the city use oxygen cylinder for breathing in the late evenings. Okay. So then we also quantified how many trees are there in Bangalore using remote sensing data and also the ground data. From the ground data, we did the mapping of trees in the region and linked that with the remote sensing data. This exercise, we did it in a couple of words. Using remote sensing data or the satellite data for the entire Bangalore, we quantified how many trees are there in Bangalore. For a population of 9.5 million, we have 1.5 million trees. That means for every 7%, one tree is there. You might ask how many trees we require. See, all of us are breathing. When we breathe, we give out a carbon dioxide to an extent of 540 grams to 980 grams per person per day. Younger people 980 grams, elderly people 540 grams per person per day. And 1 hectare of trees take away the carbon to an extent of 6 to 9 tons. By that ratio, you should have had 7 or 8 trees per person. But what we have is 7% one tree. That is where, your talent should be diverted towards the conservation of the ecosystem and innovative practices in conservation. Okay. So then we looked at what is the emission that is happening in the urban area. We looked at the 10 cities in the country, and we found the cities where the public transport is weak, we have the higher emission from transportation sector, as high as 54% from in the Hyderabad and 45% from the Bangalore, the emission. You know that when you look at the other aspect, say in Bangalore, is this kind of architecture. Glass facade building is also contributing to the global warming. We did a study of 3,000 households. In the normal building, if the electricity consumption per person per year is about 750 to 1,700 the units per person per year, in the glass facade building, it is about 14,000 to 70,000 units per person per year. That means 10 times higher electricity consumption, which means 10 times higher emission. That means unplanned urbanization has led to loss of ecosystem, which also enhanced the pollution, which has led to the warming of the global warming. That means Bangalore and Chennai, Hyderabad are contributing to global warming through the unplanned urbanization. Consequence of that is we are paying in the form of the changes in climate. Okay. So this is gives the number of lake that we have lost. And you see that how the Bangalore has changed. Temperature in 90s was 21 degrees, has become 24 degrees in 2000 or 28 degrees in the 2010. Today, 34 to 37 degrees. If you want to understand the role of vegetation and water bodies, you move from the center of the cities. When we move from the center of the cities in a direction, you see that wherever water bodies are there, temperature is 2 degrees lower. Wherever park is there, temperature is 2 degrees lower. Even in my campus, because we have a good vegetation cover, we have lower temperature of 2 degrees. Okay. Then, the consequence of the the changes in climate with this one is the flooding happening in the city quite often, and that is because of the loss of interconnectivity among the lake. You see the lakes were interconnected. Today we have lost the interconnectivity because of the encroachment of Rajakaluways or dumping of solid waste and building debris in the Rajakaluways. Okay, and other thing is you see the lakes are being abused. People dump the solid waste and the liquid waste. For example, Berlandur Lake, when it is cleaned, it was like this. When the lake is polluted, you see the profuse growth of macrophyte and frothing of the lake under fire. When the frothing happens, it indicates that the lake is in a bad state. When the lake is covered with the macrophyte, the invasive species, it indicates that there is a higher amount of pollution in the thing. The consequence of that is because there is no sunlight penetration, you do not see algae growing there. See, because of absence of algae, zooplankton is not there. Because of that, fish population comes down. That's where the worth of the lake comes down from 10,500 rupees per hectare per day to 20 rupees per hectare per day. Okay. Now the other consequence is when we pollute the water bodies is what will happen on the human health. Let us try to understand. The fish grown in the lake is eaten by the people. Similarly, the water in the lake is used for cultivating the vegetables and other crops. We did the analysis of the fish sample as well as the vegetable sample. We found the higher amount of the heavy metal in the greeny vegetables, the green leaves, etc. Similarly, radish, egg, and the fish, and even in the milk. So that's where the number of cancer and kidney failures in the city has gone up. So for your information, Bangalore is on the top as far as the cancer instances is concerned. Similarly, the kidney failure, which was 1 in 1 lakh about 12 years back, today it's 1 in 5,000. So that means more and more people are losing the kidney because of the contamination in our food. Contamination of food is happening because of the polluting the lake and the land. So we took up the rejuvenation of the lake, the thanks to the National Green Tribunal. And we also looked at how to decontaminate the lake. One of the procedure is to remove the silt. For that, we did the sampling to find out what is the quantity of the silt accumulated. See, this is an innovative way of doing the quantification. So we found out what is the historical depth and what is the current depth. The difference gives what is the silt accumulated. So our quantity shows that about 11 million cubic meter of the silt is there in the Belandur and the Vartur. Now, removing this silt, people said that it would create a traffic problem. Then we looked at the economic viability of the thing, converting into the brick. The worth of the silt is about the 1,500 crores. We also found that this silt has higher amount of the nutrient. For example, Vattur silt does not have any contaminant, whereas the Belandur some part has the contaminant which has to be handled carefully, whereas the Vattur silt doesn't have any pollutant, any contaminant. When you look at the quantity of NPK in the silt, the quantity of N that present in this silt can fertilize the soil in Punjab. Similarly, if you look at phosphorus, P in the silt, it can fertilize the soil in Uttar Pradesh. Similarly, if you look at the potash, it can fertilize the soil, the entire the soil in the Andhra Pradesh. So that means if you give the economic value, it is about 15,000 crores. Then we had a discussion with the farmers in the Vartur region, Vartur village, and about 400 acres of land. We gave the silt. This is the team which worked. There are the army people joined hands with us. Local people used to interact with us, and also the school students used to take part in this experiment. And the silt what we gave to the farmers, when I visited the lake after 3 months, the farmers invited me. They showed the bumper crop. Each farmer told me they had additional revenue of 1.5 lakh per acre. That is mainly because of the nutrient rich silt, there was no need to use the fertilizer. That means there was no extra expenditure. Similarly, because of the nutrient rich silt, they had a bumper crop. So that means they had additional revenue of 1,50,000 rupees per acre. You can quantify, multiply by 400 acre, you see what is the worth of the silt at the local level itself. Okay, now I am at the concluding part. In another 5 minutes, I will be winding up. See what you can do. One is your talent should be invested towards the managing the environment. For example, the waste. We need an innovative, novel solution to manage the waste treatment. Okay. Similarly, how to make sure the Bangalore has sufficient water or any part of the country. Similarly, how to ensure there is the water in each ward. Some of the example I will give what we have done. And also the other thing is the environmental education. What I am doing is sensitizing the youth so that they become knowledgeable about the environment. Once they have adequate knowledge, they become sensible. When they become sensible, they will be responsible. That today's youth, tomorrow's decision makers. So that's where when you become decision maker, you with this knowledge, you can take away the responsible decision. So that means we'll have sustainable development in the region. Now, if you want to understand what we have done, let me take you to one of the example of the lake. See, Jakur Lake, when I studied way back in 2005, surrounding this lake, there were 30 wells were there. When we analyzed the water quality of the wells, of 30 wells, as well as the Jakur Lake, there was a nitrate in the water, in the well as well as the lake. Nitrate is a carcinogen which introduces cancer. So then we pushed the government to rejuvenate the lake. When the government they took up the rejuvenation, they constituted a committee. I was a member of the committee. At that time, the government said they can put only secondary treatment plant. The nitrate was getting into the borewell because the people were discharging the untreated sewage into the lake. Untreated sewage has the nitrogen because we all eat protein. That is where the nitrogen gets into the sewage. So that means as the nitrogen moves towards the groundwater, it gets oxidized. You have the nitrate. So now, if you look at the treatment plant, there are three levels of treatment: primary, secondary, and tertiary. Primary treatment will remove the large particle. Secondary treatment will remove the chemical ion. Tertiary treatment will remove the nutrient like N and P, etc. Now, the government, the proposal of putting the secondary treatment plant wouldn't have removed the N. So then what I did is I integrated constructed wetland and algal pond. When the secondary treated water passes through this constructed wetland and algal pond, there's a removal of nutrient to an extent of 85 to 90%. This report is available online. Those of you who are interested can download this report and see that the last 10 years results we have shared in this report. Okay. And today, surrounding this lake, there are 300 borewells. When we analyze the water quality of borewell as well as the lake, there is no nitrate. That means my science has given the people at least the clean water for 300 well users. Okay. So then if you replicate that model in the Bangalore, you will have 16 TMC of water because Bangaloreans use about 18 TMC of water. Now, if you look at how much water is available in Bangalore through the rain, Bangalore receives about 700 to 850 millimeter rainfall. If you harvest the rainwater through the lake, you will have 15 TMC of water. You can harvest the rainwater through the roof, rooftop harvesting. Individual houses will have 3 to 4 months additional water. Then through the lake, that means at the community level, you will have the clean water. You have 15 TMC because of rainwater harvesting and 16 TMC because of treating the wastewater. That means you will have 31 TMC of water. So 31 TMC of water in a region where the demand for water is 18 TMC. So for this to happen, I have 5R formula. First R is the responsible. When people are responsible, they rejuvenate the lake so that I can retain the rainwater. And also they will allow the reuse and recycle of the wastewater. So that's where I'll have 16 TMC of the treated wastewater along with 15 TMC of the rainwater, which gives the water for everyone in Bangalore, not the select few who are elites. Okay. So now other initiatives. See, in our campus, we have created a lake. This was created in 2008, which stores 10 lakh liters of water. This is used by my student to do the biofuel research or the algal research. Not only students are happy, even we have the otter. Otter, we do not know from where it has come, but otter is there, which is a voracious eater of the fish. When we did the biodiversity study, we were surprised to see the lake has the enough algae, zooplankton, and the fish. The message here is if you facilitate the ecosystem, the nature knows how to build the food chain and provide a food for all the entities in the thing. And the message here is, I stay on the campus. I require about 500 liters of water for my family in the campus. That means per year I require 1 lakh liters. What I am doing is about 10 lakh liters of water I am storing in this lake. That means the 10 times what I am consuming, I am putting it in the form of a clean water in the lake. If every citizen does this, there won't be a scarcity of water on the earth or any part of the globe. That's what I do. When I meet people, I also give the technical knowledge about how to create the water body. That's what we did in Mudbidre, which underwent the drought situation in 2014 and 15. 2016, these people were anxious about the water. When they met me, we gave a proposal to create the water body in their campus of 12 acres, and which was created within a week of my submitting the proposal. In June, when I submit a proposal in the May first week of 2016, June first week, when there was a rain, we see the enough water in the thing. The success is because of the youth. See, wherever there is a youth, there is a sensible decision happen, and there is a success in our endeavor. So that's what. When I saw the success, everyone is young, the saint is young, and also the Alva students are young, and Alva C is also young. So then the next year, I convinced the Alva CEO to create the water body and to take up the native species planting in the campus. This stores 25 lakh liters of water. When I visit the campus in the 2018, or after 1 year of creating the water body, I see abundant the greeneries with the water in the region, and there's a smile on our face. You see that wherever there is a resource availability, there is a prosperity. That's what you can see here. Then, see, we also undertake the planting of the trees in the campus. This is a occasion when one of my colleagues passed away. On the 12th day of his death, we just got the school children and got about 500 the sapling of the ficus species, 5 varieties planted in the campus, and the children visit this on their birthday and water it. So that's where the maintenance also happens. We also solve the problem of the guard. For example, in Gokarna, there is a pond called Koti Tirtha, which was stinking. When the local youth approached us, we looked at the water quality. We saw that the water quality is deteriorated because of the organic pollutant. Organic pollutant get in because of the rituals. When people perform the ritual, they leave those rice balls and banana, etc., in the water body, which decay, and it was giving the smell. Then I had a meeting with the priest, and I convinced the priest to dispose this at a particular designated place. We named it as Vaikunta, and also the priest have to chant and collect, 25 rupees per family for doing the ritual. In the process, 200 to 250 rupees per family for this. Every day, about 150 to 200 family does the ritual, and every revenue of about 20 to 25,000 we have per month, which was given to NGO. NGO has put 3 youth. Their job is to take out the excess rice balls from this and give it to cattle in the Goshala, and they do the deweeding of the lake thrice a week. And in the meanwhile, I also introduce the fish which eats the rice. So now, because of no contaminants, the lake which was like this looks like this. This lake water is used for Abhisheka of Lord Shiva in Gokarna, and in front of Lord Shiva, Ganesha is also there. Now, this gods are getting a clean water because of the intervention of the science. The scientists can solve everybody's problem, including the god problem. That is what is the thing. See, when you are talented, you can solve the societal problem. When you solve the societal problem, you will see a god in your action. So that's what should happen. That is where this kind of talent program will make you to think. You should think positively and see contribute towards the nation building. So now, if you come to my campus, you will see the climber in the campus. I was fascinated by this architecture. When you look at this, the climber, you see it is clockwise, then the anti-clockwise, and there's a gap. So this prevents the coiling. The same analogy is used in the telephone handset. To prevent coiling, you have the clockwise, anti-clockwise mechanism. In front of this building, when I was fascinated, I brought this seat to the Bangalore. The pod had 14 seats. Out of 14 seats, 7 seats I have kept in my lab, and 7 I have planted in various locations in the campus. Out of 7, only one location it has survived. That is next to the building where I am working for the last 2 decades. That means even the plants know how to take care of who takes care. That's where it has survived there. So in front of this building, we created a mini forest in 2 hectares area way back in 90s when I was a student. In a 2 hectares area, 49 native species, 500 saplings were planted. Today, when you look at that region, you get a feel of the rainforest with a rich biodiversity. You see the population of the slender lories, varieties of snake, etc. Apart from that, you look at the groundwater table, which was about 150 feet when the region was covered with a parthenium or invasive weed. Today, I have the water at 10 feet. What I was talking in my science is happening here, and temperature is 2 degrees lower. Earlier I mentioned that the vegetation and lake act as a heat sink. Now there is a demonstration of that. You see that 2 degree lower temperature there. And also it's a hotspot of diversity. Where the presence of 4 families of slender lories further highlights the sun. That is where when you have the this kind of forest in each ward, your groundwater problem you can solve in the ward or in the village. Okay. Now to communicate, we communicate to the youngsters. You see my audience. We also go travel, go to the rural school. We educate the younger children in the rural area. And also we offer a course for the adults, working in industries and universities, etc. I have offered a course on environmental management for the last 20 years now. Okay. And another thing is maybe you all would be interested is I organize a symposium popularly known as Lake Symposium once in 2 years. I've been doing it from 98. The last event was during 2022. That's the 13th event. Uniqueness of this event is there are about 1,000 to 1,200 people that participate, and about 20 to 30% are the school and college students. When they attend, they listen to the experts talk, their knowledge gets enhanced. Not only that, they also do the presentation on the concluding day. The next event is going to be in the month of October. During 17th to the 20th of October, it would be at Alva's Mudbitri. When you visit, you can take part in the symposium, as well as you can see the lake in the Mudbitra campus and also forest in the Mudbitra campus. And the school children, the kind of experiment they do is the children are measuring the carbon in the trees. Similarly, the children's where the lake is in the close proximity, they do the mapping of trees in the catchment. They do the water quality assessment. Here, children are trained to do the water quality. They go to the field, they collect the sample, they analyze. Similarly, in rural area, the children do the biodiversity mapping in their village. Okay, that's how the knowledge get enhanced. And you say that if you have more data, if you want more data, you can write to me. My email ID is tvr@iisc.ac.in. I do not use mobile, so don't ask for mobile number. Okay. And my publications are available at this portal. These are various portal where my research group publication is there. The related to biodiversity, climate change is available here. And if you are interested in the free and open source software, this is the website. And all our publication is updated regularly at this portal at the international level, ResearchGate and Google Scholar. Okay, so now when you access the web page, you see our publication, the PDF are available. You are most welcome to download, read, and enhance your knowledge. But please don't copy and paste it in your assignments. And similar lectures, what I have given is available in YouTube. You can give the Google search YouTube, TV Ramachandra. You will see my TED talk, etc. Okay. So, and this gives a glimpse of the children doing the experiment in the water testing laboratory in the schools and colleges. Okay. So our initiative also helped in designating the Aganashni wetland as a Ramsar wetland. Our 2.5 decade research in the Uttar Kannada district helped in compiling the information related to the flora and fauna in the region, and also the social relevance of the ecosystem. We prepared a report based on that. Our study. This is the report submitted to the Ramsar Secretariat on with a lot of persuasion. On 2nd of February, it was declared as a Ramsar wetland of international importance. That's how we have taken the science to the society. With that designation, everyone in the globe will know the significance of this wetland. They will start visiting. The ecotourism will bloom in the region, and local people will have the revenue. So, our agenda is to sow the seeds of knowledge in the young brain, and they become talented. When they become talented, they become asset to the nation. We are looking for more and more the talented youngsters in the system. I invite you all to the Lake Symposium. which is going to be during 17th to 20th of October at Alvas, and we will soon post the brochure at various websites and social medias. You can download and you can register for the program. So, and the success of our program is because of the youth. See, when the youth does a wonderful job, there is a smile on everybody's face. Thank you very much for listening to me. See, I started my presentation at 4:15 because there was a technical issues. Thank you for listening to me. Okay. Okay. Thank you all.
Thank you very much, sir, for a very informative and scholastic talk from basics to how climate change is affecting humanity. You spoke so well, even a person without biology background could easily understand. On behalf of KSTA, we are very grateful to you, sir, for your time and wonderful presentation. Now, I request attendees, if there are any questions, please, sir, can type it on chat box. Sir, there are one or two questions.
Yeah, sure. I will respond.
Yes, sir. How can climate resilience address the disproportionate impact of climate change on vulnerable population? Shall I repeat it, sir?
Once again, I'm just reading that.
It is through email.
Okay.
How can climate resilience address the disproportionate impact of climate change on vulnerable population?
See, the population become vulnerable only when you are exposed to the changes in climate. For that, you need to have a resilient system, climate resilient system. See, if you are practicing agriculture, you grow the climate resilient crop. Do not waste the water. You conserve water. You minimize the wastage in the system. Manage the waste properly. And if you are traveling, don't emit. Try to be the nature friendly. As far as possible, bring down the carbon footprint. When every citizen on the earth bring down the carbon footprint, naturally the earth becomes the more resilient and there won't be any vulnerability in any part of the globe. That's what we should do. And also there has to be a technological improvement has to be there. That is where innovations are required. For example, in the energy sector, there need to be improvement in the industrial process. We need to enhance the end use efficiency of our machineries. That is where the students and youngsters have to take part in the engineering and the science part of it to bring down the inefficiency in the system, inefficiency in the machinery, inefficiency in the working environment, inefficiency in our day-to-day life. If we can bring down all those inefficiency, we will certainly have the climate resilient system so that all of us can live on the earth. As you all know, we have only one earth. We need to say the respect Mother Earth. If you do respect Mother at home, you will also think of respecting the Mother Earth. I would say that first message is respect Mother at home. Then you will think of Mother Earth, and you will lead a life which is climate resilient. Okay.
Thank you, sir. One more question. How does climate resilience differ from climate mitigation and adaptation?
Can you repeat?
How does climate resilience differ from climate mitigation and adaptation? Is it the same or different?
No. Mitigation means you are bringing down reducing the thing. For example, when you, instead of fossil fuel, if you start using the renewable energy, you are mitigating the carbon emission. That means you have brought down the carbon emission. Then when we talk about adaptation, I gave an example of an organism getting adapted to your situation. When you become warmer and warmer, you will get adapted to a situation so that you will make your own adaptation and do that. Resilient means you are resisting the changes. For example, if you grow paddy, you have more and more water requirement, and so the temperature, it is vulnerable to temperature. Instead of that, if you have the millets or the pulses, your water footprint comes down. For example, to grow a kg of pulses or millet, you require about 150 liters to 200 liters. Whereas a paddy and wheat, you require 3,000 to 5,000 kgs, 5,000 liter per kg of rice and wheat. Similarly, for sugar, you require about 12,000 to 15,000 liters of water per kg of sugar. Now you know that if you want to bring down your water footprint, you need to go for the crop, which incidentally is also a resilient crop, which will not get affected because of changes in climate. With the increase in temperature, your yield won't come down. Rather, yield will go up. So that is where the resilience helps. Okay. But when you make the region vulnerable with the changes in climate, you will have the consequences of flooding and more, the loss of life and property will happen. So that is where we need to be very cautious and we need to be very careful when we practice our day-to-day life. When we minimize our waste footprint, when we minimize our carbon footprint, if we start using more and more metros and public transport, even you are economically the well off, I would advise you to use the public transport. You are not going to lose anything by going by metro or the bus. Even today, I travel by that. And sometimes people come and ask me, sir, why are you traveling by the thing? They think that I am too stingy. I am too stingy when it comes to environmental issues. I don't want my next generation to have a vulnerable situation. If what I preach, if I practice, then more and more people will do the same thing. That is what should happen. Then we'll have a resilient system. You look at all the appliances at your home, try to bring down the carbon emission. Okay, if you have for example, television of earlier time, okay, switch over to the LED so that your electricity footprint comes down. If you are using a fluorescent lamp or a tube light or an incandescent bulb, switch over to LED bulb. Fluorescent lamp of 40 watt, the LED bulb of 9 watt give the same illumination. You are saving the electricity. And life of the bulb, LED bulb is 9,000 hours compared to the 1,000 hours of the tube light. That's where if you start practicing that, then naturally you would have brought down the carbon footprint. Your agenda should have been to minimize the carbon footprint in your day-to-day life so that you are safe, your parents are safe, and tomorrow your children will be safe. So that we have the whole system which is secured for everyone and there won't be any conflict in the system. Okay.
So thank you very much, sir, for wonderful presentation as usual. It was really informative and insightful. And I'm sure many students and teaching faculty who joined this webinar will certainly would have broadened their horizon of knowledge on climate resilience and how to reduce carbon emission. Thank you very much. Sir, please.
Yeah. Once again, I saw a comment saying that somebody has written that they couldn't see the Western Guard decision support system. I will just share that thing
Please,
and just alert me whether that is visible. Okay.
yes, sir.
So, is this visible?
No, sir. Now it is visible. Yes, sir. Yes, sir.
Okay. See, our website is wgbis.ces.iisc.ac.in. This is Western Guard Biodiversity Information System at Center for Ecological Sciences at IISc. Okay, when you click on Western Guard Spatial Decision Support System, you will see the layer with the eco-sensitiveness at 4 levels in the Western Guard, entire Western Guard. You can also see that at village level. Each village you can see that for the entire Western Ghats. Okay. Then if you want to see at the state or a district or a village level, you can choose. For example, I will choose Karnataka. Okay. So now Karnataka is visible. I will go to the district, the Chikmagalur. Now you can see the Chikmagalur. Sir, is it visible, Chikmagalur?
Yeah, it is visible, sir.
Okay. Then I will choose the taluk. So I will choose the Sringeri. Okay. Now I'll select the village.
Yes, sir.
Incidentally, all are ecologically sensitive villages in Sringeri, and you will get the details of the eco-sensitive thing. Why we have considered as ecologically sensitive? What are the variables that merits the ecological sensitive? Like when you score, if you get a CGPA of 9.9 out of 10, which are the subject you have scored and which subject you didn't score out of 100. Okay, so that is the kind of detail you'll get. And also all the data what we have used you can also visualize that. See, whatever the data my group has compiled over the last 2.5 or 3 decades, we have made it public.
Yeah.
Okay, that is available to everybody. Not only that, not only the Western Guard. If you look at recently, we launched the Bangalore Urban Information System also. That gives the Bangalore this one. You can visualize what I presented today. That is also available online. Sir, can you see the Bangalore?
Yes, sir. Yes, sir. It's visible.
Okay. Then similarly, we also, if you look at, we also try to put the Bangalore Lakes Information System, it's known as BLITZ. So you see that all the details about the lakes and, algae, which lake, what kind of algae, the zooplankton, then also the fish you can get, and also macrophyte. And also we have tried to put which lake, how much is encroached. And also when people do the rejuvenation, what is the level of rejuvenation? We are going to put. That means whatever science which I have done, I have compiled the data, I have made it public, so that people have the information, they can take appropriate decision. So that means the science, what I have done, is not just converted into publication which are there in my alberas. I've also made it publicly available through this kind of decision support system. And if you look at my web page, you will see all the publications are available in the web page. So you can see all the publications we have made it available, and PDF version people can download and then have the thing. Okay. So
Thank you very much,
yes,
sir.
sure, sure.
Thank you very much.
Because there was a query, I thought,
There
let
is one
me
more
respond.
question from Durga.
Okay.
Anthony, please unmute Durga. She wants to ask question to sir.
Okay, okay. Please admit. Miss Durga, you can ask question to sir. Hello.
Anthony, please unmute her.
Anthony, unmute Miss Durga. Anthony.
Well, there is some comment by Durga in the chat box. He says paradoxical growth in India. See, our decision makers of today belong to the colonial period. They were graduated when colonial rulers were there. Because of that arrogance was there, that is where you see the unplanned urbanization has happened. That is where you see that kind of growth. They think only of GDP, not about the livability aspect of the human being in the country, or the citizens in the country. We should have chosen the green GDP instead of GDP, like Bhutan has done. Happiness index should have been our criteria. We should have made everyone to be happy, not just only select few to be happy. That the pattern of growth, we need to curtail it, and we need to alert the government, at the state as well as the center, and see that our government the decision makers start taking appropriate decision, so that you have a better the livability in every city or the village in the country. That is where the decision makers should be environmentally literate. When they are environmentally knowledgeable people, then you will see the growth, which is a holistic growth. Everyone gets a benefit, not only a one section of the society. Okay.
Just a moment, sir.
Yeah.
Yeah. Am I audible now?
Yes, you are audible.
Yes. Thank you, sir. Sir, in terms of, sir, I'm extremely happy to hear your presentation, and a lot of things to introspect upon, and a lot matters on how are we perceiving things at our end, and how are we reciprocating the results or the findings at the other end. Sir, I have a doubt. So one way we say that our like if you take that annual average per capita water availability, that had declined over the years if you look at. However, still we say that we have at our disposal the highest water availability today, which is around 1,000 billion cubic meters per year. However, if you look at the toll is different in terms of per capita carbon dioxide emission in India. We are still one of the lowest in per capita carbon dioxide emissions. So here, sir, there is, as you rightly told, as we link GDP with each and everything, there is actually a problem, is because we are linking economy with natural resources, which cannot be equated. So can we have a combined roadmap which could be suggested to ministry, wherein the water, the energy, and the resources availability can go hand in hand? As you rightly suggested, we can have GDP not the index of the growth, but something else that you rightly mentioned. So could you please throw some light on that index?
No, one is that, that is where, the United Nations also has come up with the standard framework to do the natural capital accounting and valuation ecosystem services. So with that initiative, every country will know the worth of the ecosystem in their region. It could be the terrestrial ecosystem, aquatic ecosystem, etc. So once that is known, the cost of the development also can be looked at. The cost of development, when you have the project, only what is the benefit you got out of the project you are accounting in the GDP. What the natural capital accounting and valuation ecosystem services will do is, you can also include the degradation cost of the project, so that once you start putting the degradation cost along with the project, then your GDP, which was now bloated, may not be the same number. So that is what, then people become more conscious and they will start practicing the thing. Then there will be a better management of the system. That should happen. Now slowly the things have started in the country. As a pilot, we have done it for Karnataka. Now this initiative is going to be scaled up in other districts, in other states in the country, with the World Bank funding. And over a period of another 2 or 3 years, I think this whole thing will have a clear picture about natural capital accounting and worth of our natural asset in the country. Once we know the worth, then we can bring down the exploitation, the over exploitation, and the mismanagement. That's what we are looking forward. That is where science will help. That's where youngsters like you are required in the system, and who should also be active. This kind of work will not be this one long-term project. For example, seeing my publication of Uttar Kannada district, United Nations approached me. And when they approached me, they said that, can you do it for 10 districts in Karnataka? And you can do it based on the United Nations, the framework. We adopted that SIA framework, which was developed by United Nations. We started the work. At that time, COVID also came into the picture, and we were not be able to move to the places, etc. But fortunately, it helped me. So because of the COVID, I was not traveling for the meetings, etc. Instead of traveling to the Delhi and meeting the Babus, I started going to the Western Ghats and the Karnataka, the other parts of the Western Ghats, not just 10 districts. We did the natural capital accounting for all the 30 districts or 31 districts in Karnataka. And when I submitted to the United Nations, they were so happy when I was invited. When I presented this for the United Nations audience, then some of the countries were surprised. They thought that Indians means we are dull fellows, we are slow fellows kind of thing. They asked me the thing, sir, how the things are. I said, you have not understood us. When you look at us, we look dull. But our capability, we will not expose it unless the challenge is posed on us. That is what has happened. And today, based on our work, the World Bank has come forward with a big money, and blue economy, natural capital accounting, the protocol is being finalized under the Ministry of Statistics program implementation. That program will be implemented through the various institutions in the country, including the IISc. Okay. So the things are changing and it will happen. But for that to happen, this knowledge is a requirement. And for that, this kind of programs will certainly help. I'm sure some youngsters in the audience will start thinking about the nature and will start thinking about how to minimize his footprint in the system. So that, once we start doing it, if I get one person in every talk of mine, I think I've done my job of sensitizing the system. Okay.
Of course. Thank you very much, sir, for the wonderful presentation. And the enlightening talk. It will just not give a lot of platform for us, but also a lot of thought process to be used and implemented. Sir, as you rightly told, if we can actually settle a zonal center at every north, south, east, west zones in India with some of the IITs heading, and IISc could coordinate that so that we can bridge the gap by having information from all these zones, and it could be compiled together. That would be a good way of state-wise or maybe a district-wise, economic blended with developmental model, rather than just following a GDP as a frontier step for assessing the economy and the growth of the country. Thank you very much, sir, for the presentation.
That is the one thing. Another thing is, even if all the institutions are not joining hand, if I get about 20 youth, talented youth, okay, and with the artificial intelligence and machine learning and their will to work, we can get it for the entire country. It's not
Of
difficult.
course, sir, that will happen, sir. Of course, if we get the opportunity, we will be very much happy, sir. Thank you very much for the talk, sir. Thank you so much.
Okay, thank you. All the best.
Thank you, organizers. Thank you, Umesh, for the opportunity.
For interacting with sir with good questions. Thank you very much, sir. Once again, thank you.
Thank you. Thank you for giving an opportunity to interact with the youngsters. Okay. Thank you all. Sure.
Audience, thank you very much for being with us for this excellent, insightful talk by Professor Ramachandra sir. We look forward to your kind support in future as well. You can spread the message with your friends so that when next time sir gives a talk on different aspect of environment, they will be enlightened again. Thank you very much.
Okay. Thank you. Thank you all.